Welcome to this introduction to the binomial expansion. So this will be of interest to people in their first year of A-level and also those in year 11 doing additional mathematics. Okay, now the binomial expansion refers to a binomial, which is a bracket containing two terms raised to a power. Okay, in other words, multiplied by itself many times over. So I'm going to start this by just carrying out an expansion of a couple of these brackets, and then we'll look in more detail at what we get as a result. So the first one, a plus b squared, well, this one is obviously just a plus b. The second one, a plus b times itself, we would normally write down as two brackets side by side containing the same thing, like that, you see. And then we would use FOIL, first, outer, inner, last, which makes sure that we multiply each term in one bracket by each term in the other. So we've got a times a is a squared. We're going to get also an AB and a BA. When you add them together, you get two lots of AB. And the last term is going to be made from the B and the B, which is b squared. Okay, so you should be familiar enough with that. Now, if we took that result that we've just written down and multiplied that by a plus b, it would give us a plus b cubed. Okay, so I'm going to do that now. Here's a plus b in front of the result that we just had. Okay, so that was a squared plus 2ab plus b squared. Okay, and if we multiply that out, we're going to get 6 terms. Okay, and 2 pairs of those will combine to simplify. So we'll take each term from here and multiply it by a first of all. So we're going to get a cubed. We're going to have 2a squared b, and then we're going to have a b squared. Okay, and then we take each term in the second bracket and multiply it by b. So it's going to give us a squared b. Then it's going to give us 2 ab squared. And finally, it's going to give us b cubed. Okay, and that's 6 terms, which will simplify into 4 terms, giving us a cubed. Okay, in total we have 3 lots of a squared b. Okay, we also have 3 lots of a times b squared. And finally we have 1 of b cubed. Okay, so that's the full simplified expansion of a plus b cubed. Now, if I were to do the same process again, in other words, take that result and multiply that by a plus b, I won't do it now, I'll just leave that for you to do, but it will give you a to the 4, okay, plus 4 lots of a cubed b. Then it will be 6 lots of a squared b squared. Then it will go to 4 times a times b cubed. And finally, it would give us b to the power 4. Okay. And if you were to take that result and multiply it by a plus b to give you a plus b to the 5, I'll just start to write it out. I won't do the whole sequence or the whole series. It's a to the 5 plus 5 lots of a to the 4 times b. And then the next term would be 10 lots of a cubed times b squared. Okay, and then it would carry on with another 3 terms. But as I say, I'll stop there because that's enough for me to explain what's going on. All right. So the key thing here is that we're getting these numbers that seem to form some kind of pattern and are predictable. And I'll show you where they come from. Okay. If I bring this thing up here, you've probably seen this before. This is called Pascal's triangle. All right. So basically, you've got these ones down the side, and each row, if we take the third row, the 2 comes from the sum of the two numbers above it. So 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 1 is 3. Okay, if we go to this row, 1, 4, 6, 4, 1, the 4 comes from 1 plus 3. The 6 comes from 3 plus 3, and so on. You've got the idea. All right. And of course, by now you can see that the connection between these rows and the coefficients is very clear. So here we have 1a squared, 2ab, and 1b squared. 1, 2, 1. In this one we have 1, 3, 3, 1. 1, 3, 3, 1. 1, 4, 6, 4, 1. 1, 4, 6, 4, 1, and so on. So that will always be true, and Pascal's triangle will generate these coefficients. Okay, so let's look at why these numbers come about. Let's take, for example, this here, the 4 in front of a cubed b. Why is that the number 4? Let's consider this. We could write a plus b to the power 4 as a plus b times itself 4 times. Okay, that's what we actually mean by a plus b to the 4. Now, if we were to carry out that multiplication of 4 brackets, okay, which we've done in stages, we could look at it this way and say, right, a cubed b, that can come from multiplying together 3 a's and a b in any order, okay? Because it doesn't matter what order you multiply things together and you get the same answer. So how many ways are there of me getting 3 a's and a b from these 4 brackets? Well, I could have an a from there, an a from there, an a from there, and a b from here. That's one way. I can have an a from there, an a from there, a b from there, and an a from there. That's another way. And in total, there are 4 ways of this happening. There they are. Okay. Now, if we took another term from here, let's look at the this term here with the 6 in front of it. The coefficient of a squared b squared is 6. So that means there are 6 ways of multiplying together 2 a's and 2 b's. In other words, 6 ways of selecting 2 a's and 2 b's from these 4 brackets. Okay, so I could do a b and a b, or I could do an a b and an a, and so on. And what are the 6 ways? Well, I've listed them all here so you can see, and there they are. Okay, and that accounts for the 6 that we see in front of a squared b squared. And I'll just take an example from this expansion here. Let's look at this 10 that appears here. Where does the 10 come from? It's telling me that if I had 5 brackets, in other words, the first 4 plus another one, okay, I'll just illustrate this for you. If I took those 4 brackets there, okay, I'll just make a copy of that and bring that down there. Okay, and if I put next to it a 5th one, a plus b, okay, so what I'm now asking is how many ways are there of choosing 3 a's and 2 b's? Okay, well, I could have an a, an a, an a b, and a b. That would be the first thing I would think of. And in fact, there are 10 different ways that this can happen. And here they are. Okay, so they're the 10 ways in which you could choose 3 A's and 2 B's from 5. So these numbers, 4, 6, 10 here, are numbers of combinations. That's what we actually call them, the numbers of combinations. So, for example, this 6 here, okay, comes from what we call 4C2, okay, 4C2. And there's a button on the calculator called NCR down the right hand side, and that shows you how, that enables you to get the number of combinations. And 4C2, which is what this 6 is here, okay, that's the 4C2, okay, can also be written like this as 4-2, okay, so that can also be written as 4-2 as a sort of column like that with brackets around it, okay, and it means if you had 4 items where 2 of them were different from the other 2, how many different ways could you arrange them? And it comes to 6, and the calculation that leads to the 6 is actually what it means, which is 4 factorial, okay, over 2 factorial, so that's where the 4 and the 2 come in, multiplied by 4 minus 2 factorial, which is also 2 factorial. Now, if you're familiar with the factorial notation, 4 factorial is 1 times 2 times 3 times 4, which is 24. 2 factorial is 2. So this is 24 over 4, which is, of course, 6. Okay, if we took one more example, let's use this 10 here. This 10 is the number of ways of arranging 5 things where 2 of them are the same, okay, and 3 of them are different to the other 2. So it can be written as 5C2, okay, and that means 5 factorial, which is 120, 1 times 2 times 3 times 4 times 5, over 2 factorial times 3 factorial. Okay, and by the way, 5C3 would be 5 factorial over 3 factorial, 2 factorial, which is the same value. But in any event, that comes to 120 over 12. Okay, and you could test it on the calculator, but that, of course, is 10, which is the number we have in Pascal's triangle here, and the number we have here. Okay, so that's an introduction to combinations and the number of ways of arranging a certain number of things within a larger group. Now, there is the general formula for the binomial expansion, which appears in the A-level formula booklet, and you just need to be familiar with that. So a plus b to the power n can be written as a to the n plus, this is nc1, this is nc2, this is nc up to whatever number you're going to, you see. All right, and you notice how the powers of a go up, the powers of a go down as the powers of b go up. Okay, so here we've got a to the 4, a to the 3, a to 2, a to the 1, whereas the b is going up, b to the 1, b squared, b cubed, b to the 4. All right, so there's a kind of a pattern to follow there. N is a member of the natural numbers, simply means that for this expansion, n must be an integer, a whole number that's positive. Okay, I hope that was helpful. In the next video, we look in more detail at some practical examples of how this might be used. Take care.